Hey guys, what is up? We are going to be checking out two really cool things today. The first thing we're going to be going over is physics. So you can see I've got this circle, and the circle hits the box, and the box goes drifting. The other cool thing is we have lighting, so you can see the shadow cast here and over here by the lights. You can see how the lights interact with each other. As this drifts away, you can see we have a texture here, and it gets darker as the light comes and goes. So we're going to be making something similar. We're not going to add all the bells and whistles, but we won't worry about implementing controls, but we'll just knock those boxes out of the way. Yeah. But we'll get the lights, and we'll get the circle, and we'll have this circle affected by gravity, and we'll go from there. So to do this, you're going to need three things. The first thing you're going to want to have set up is Libgdx. If you don't know, this needs to go away for life. If you don't know what Libgdx is, just watch my first video. I go over how to set it up. There's a GUI setup tool that you can use, and it sets the entire Eclipse project up for you, which I suppose you can say you want Eclipse to do this too, so maybe add that to the list of things. You're also going to want Box2D. The nice thing about Libgdx is it has a Box2D wrapper built into it, because Box2D is not natively Java, and we're going to be using Java to do this. So Box2D gives us a wrapper that handles everything for us. And then outside of that, let's see, what else are you going? Oh, what's right in front of me on the screen right here. You're going to want to go to code.google.com/p, well, it's a /p/box2d lights. And basically, this is the whole, what handles our lighting. It gives us a whole lot of stuff. All you're going to want to do is click on downloads, download the latest one, 1.15. And if you want to know how to use it without watching this video, you can always click on the hello world, and this will tell you how to use it. It's really simple. You need a ray handler, you need to create a light and pass the ray handler as a parameter, as well as a few other things. And then in the game loop, you're going to call ray handler update and render, and you're going to call dispose in your dispose method when everything's done. So yeah, if you want to figure out how all that stuff works, you can feel free to go through here. You can see it actually has a couple different types of lights. You have a point light, you have a cone light, and you have a directional light. We're going to be playing more with the point light, which is what I had before. The directional light is basically something that is infinite from a direction. It's kind of like a sun, but not. And the cone light is like, picture if you're looking at a top-down view of a flashlight, so the entire thing isn't lit up, it only lights up in a cone shape. So those are the three different lights that this comes with. The ray handler handles and manages all of that, and I already have it downloaded, so we'll go into here, and I'm going to actually put the libraries in with the desktop project, I suppose. Basically, once you download it and you unzip it, you're going to have these two things, Box2D lights and Box2D light sources. Actually, let's see if I throw it in here if it'll work, because I think that way it'll work also with the Android project. So if we'll copy the files, right-click, go to build path, and configure the build path. And for libraries, we are going to add a jar, and we have already have it, Box2D lights.jar. And then if we go down here, we can actually, it'll say, is there a source attachment? We can highlight that and click on edit, and then browse, and Box2D light sources.jar. So we'll do that, and that should handle everything for us. Let's see if this works, if I did this right. Ray handler, and if it'll let me import that. Yep. All right. So that's all it takes to set that up. Really easy. So I already have our desktop, our main class set up. We're going to end up using OpenGL 2.0, but for now I have it set to false. We'll change that later. I'll show you why I made it 2.0 once we start getting into the light portion of the video. And I changed it to make it 720p. So I guess I'm going to go over the Box2D stuff first. We'll get a bouncing ball, and then from there we'll make everything else. So let's see. We'll do the lights later, but first we need, of course, an orthographic camera called camera, and I'm gonna kind of speed through this a little bit because I did this video before and it ended up being an hour, and I wanted these videos to be a lot shorter than that. Now, if you've watched any of my other videos, you've seen something called a world. I use a world class as a class that kind of manages the rendering and the logic. It kind of links those two things together. This is the world class for Box2D, and it's com.badlogic.gdx.physics.box2d is the path for it, and it basically handles a lot. It handles all the physics stuff and holds all of our objects, so that's going to be important for us. The next Box2D thing we're going to have is the Box2D Debug Renderer. We'll just call that render because you know, that kind of comes in handy. We're going to have two floats, float width and float height. That'll just hold our width and height for us, you know, should we need it. What else are we going to need? We can also throw in a FPS logger to keep track of our frames per second for us. I have the code in front of me, and some of the stuff is going to be omitted for clarity, but we will need this. Well, we won't necessarily need it, but if you want to add controls to the circle like I had before, you'll want it as a global variable. Do we need anything else out of this? I don't think so. Yeah, that should be it. Alright, now we're going to get down into our create method, and let's go ahead and import all that stuff. That's the body that we want. Alright. I'll talk more about what a body is later, but first we're going to say that width equals, we're going to get our width and our height, and we'll just divide it by 5. You know, this isn't a perfect way to handle resolution, but it works for our purposes because we're just kind of throwing a test case together. And you know, this isn't how you'd want to do it because you're putting your render logic with game logic, and it would make a nightmare to maintain. Now let's go ahead and orthographic camera. So we'll go and make a new camera, pass it width and height as that, and we're going to set up the position so that it's aimed not with 0, 0 in the center. We want 0, 0 in the center, I believe, is how this sets it up, if I remember correctly. So it just centers up our camera instead of making it so that 0, 0 is in a corner. The origin is going to be in the center. And since we played around with some matrices, we need to call camera.update. Again, a lot of this stuff is dealt with more in my other videos if you don't know how Libgdx handles camera and stuff like that. So world takes a vector2 parameter and 9.8f, and it also takes a Boolean. The vector2 is the effective gravity. So the first one is horizontal gravity, so if an object moves left or right naturally, and we don't want that. There are, I suppose, cases where you might use it, but it's not very frequent. The second one is vertical pull of gravity, 9.8 meter, and this is just a heads up, all of Box2D is set up using the metric system. So this is 9.8 meters per second squared, which is essentially the effective gravity on Earth. The Boolean has to do with a sleep. I think it's whether or not you should simulate inactive bodies. So we'll leave that false for now because we don't need to worry about improvements for as little as we're doing. Then we can work with our renderer. Yeah. Debug Renderer, there we go. That's all set up. Don't know what I was thinking typing all this out. FPS logger, that's all that takes. And now we'll worry about creating the objects themselves. So the first thing we have is a body def. And a body def handles a couple things for our object. So this is going to be the body definition for our circle. So we can look at what it handles. We're going to be worried about two things. The first is the body type, and we're going to set that to body type, dynamic body. Now I'll bring that back up real quick. And you can see that we have the options of a dynamic body, a kinematic body, and a static body. To explain these real quickly, dynamic bodies are move freely, they bounce off each other. Picture throwing two like basketballs against each other. A basketball would be a dynamic body, and when two dynamic bodies collide, they go in opposite directions. Then you have a kinematic body, which is a body that, if it's moving, doesn't stop, but things bounce off of it. So using this as an example for a game, your character is a dynamic body. A kinematic body would be, say you have a moving platform that he jumps onto. The platform keeps moving along its same axis even though he jumped on it, and it would normally, if it was a dynamic body, would go down. So it stays along its own plane, but still while interacting with the dynamic body. A static body is a body that doesn't move, but dynamic bodies and kinematic bodies interact with. So the floor is the perfect example of a static body, and that's actually what we're going to use for the floor. The next thing that the circle def actually controls is the position. So we will set the position with the width divided by 2 and the height divided by 2. So we'll put that basically at the middle of the screen, essentially. Let's see, what are we handling next? The circle body that we looked at earlier, that we have up here as a global variable, its constructor actually takes that body definition Sorry, it actually doesn't have a constructor. It's the world. The world creates a body by taking a body def. So we initialized our world up here, and it holds all the objects. So we're telling the world to create a new body, and the world handles the object creation, everything, and then returns it to us in that body. And that's how the world basically gets a hold of everything, so to say. Next, we actually need to tell it what the shape is. So since it's a circle, it is of course a circle shape. Let me import that. Alright, we're good. It's a new circle shape, and then we can just say circle shape, and we'll set the radius to say 3f. And Box2D, usually you want to create your objects smaller. I think the ideal size for an object is actually, if I remember reading the documentation correctly, is actually about the size of a tennis ball. And I believe the radius actually takes meters, so this is a little bit larger, but it handles things. I believe he said the max size that things should be is about the size of a school bus, and the minimum size is, I forget what he said. I forget what the documentation was on it, but it's something that's fairly small. So there's a wide range, but there is a kind of perfect middle, and I believe it was the size of a tennis ball. Now we need to create a fixture. So you can see that there's a proceduralized routine to creating these, these objects, and the fixture is what I think is one of the most important ones. You pass it the shape, which of course is the circle shape, if I can spell. And you basically, it handles all sorts, the fun stuff of the physics. So the density of it, the density we'll set at 0.4. But if you hover over density, it'll tell you that it's in kilograms per meter squared. So, density is mass over volume. So there you go. That gives you that. This is kind of a fun one. The friction. So when it's touching an object, the type of the drag, the resistance that it has, we won't give this too much friction. And this is my favorite one when we're doing a test like this, and this is restitution, which is basically how bouncy it is. Since we've got a ball, we'll be able to see this really well. But the higher the number, the more perfect the bounce. So if you have a restitution of 1, it should bounce just as high as when it was dropped. The lower the restitution, the less it'll bounce. If it's 0, it won't bounce at all. It'll just hit. You can picture that like how a sandbag would do versus how a bouncy ball would do. So we now have that. Now we need to pass the fixture on to that. So we need to say circle body dot create the fixture and circle fixture. So if you want, we'll I don't have a live vote, but we'll go over this one more time. So first we create a body definition. The body definition tells what type it is and where it's located. Then with the help of the world, we create a body, and the world creates the body for us and then gives it back to us once it's created for us to give more information to. Then we create the shape, set the radius, we create the how it interacts with the rest of the world, then we update the body with that fun stuff, and then we kind of move on from there. And then next, we are going to create the ground. So we'll call this body ground body. Or wait, actually, what was we need to create the body definition first. So we can say body def ground body equals a new body def. And then ground body, sorry, this should be ground body def because it's the definition, not the body. Ground body def dot position and dot set. And this will be 0 and 3. I believe that's what we want. Since this isn't a circle, the actual shape that we use is called a polygon shape. Ground box. Polygon shape. There we go. And then we need to set it as a box, and this is where we really kind of get the full effect for set as box, and I believe we just need this method, and we can just do it like viewport width. Whoops. Put parentheses around that. I don't know why I put parentheses there, but if it was needed, maybe so, maybe not. And then 3.0f. Alright. So we have the def, we have the shape. So you see that we actually did this backwards from what we did here. We actually created the definition and the shape first. Now we're going to and that's why, because I skipped a step, of course. Because why would things go out of order in programming? So we're going to create the body using the ground body definition that we had before, of course. Now we can move on. We can say ground body dot create fixture, and this actually takes a different parameter, but we have ground box and 0f, so we have an overloaded method here, and that handles the body there. But you can see that the fixture, this one actually takes a shape, so we made the polygon shape, and then it takes the density, and the density for this won't matter because it's a static static object. So let's make sure that I've got this right. In our dispose, do we have to worry about disposing anything? Yes, we need to dispose of the world. And that should be all we have to worry about for now. On to the render method. We are going to need to clear, do the clear color. We'll just set it to black. And we will actually clear the screen. GL underscore color. Color buffer bit. Right? Should be right. No? Oh, I had to import it. There we go. That would be why. Render, so we can go ahead and render the world. and it takes a projection matrix. We can just use the combined matrix for that though. And then we'll have to say logger.log because there'd be no use in having a logger if we don't do anything with it. Now is where things are a little bit, actually let's do this up here. Now is where things are a little bit different. So we have world, and there's this step method. Now this step method takes a time step, and physics requires a fixed time step, which is a little bit weird. Our game's going to be running at 50 or 60 frames per second, so we can just say 1 divided by 60. And then we have the velocity iterations. 6 is a good number to use, and then 2 is a good number for the position iterations. Changing those changes deals with accuracy and stuff like that. I'm not a pro or really know exactly what they do per se, but if you really are interested, you can. There's a really long Box2D manual that you can read. I believe it's at the website, and it explains everything for you in detail. So let's run this real quick. We'll say that and make sure it does what we want. And we have our ball that falls, boom, hits the ground, bounces back up, and that is almost exactly how we pictured it running, correct? I think so. Alright, now let's deal with the fun part, which is the lights. Now that we have the Box2D working, let's deal with the light stuff. So for this, the key of all of it is the ray handler, which handles all the lights for us. And let's see, is there anything else that I don't really? I think that's all we need. So we'll import the ray handler, and then we'll just add, at the end of this, we'll just say, nah, we don't need to worry about commenting our code here. But ray handler, which takes the world. I think that is, yeah, it is really that easy. And then you do have to do this: set combined matrix to camera, not combined, boom. We're set. Since we're not moving the camera, we can put this here. Otherwise, we'd put it in our render method or something after we manipulated our camera's matrix or moved it. Yeah, so that should be all of it. Now let's create a point light. And to do this, might be weird for some of you. Some of you won't be weird. But we aren't actually going to hold a variable of it. All we're going to do is just say new point light. This one. It takes the handler. How many rays do we want? Usually you want this to be a lower value, but for the sake of it, let's put 5,000 because we're gonna have some fun here. The color, we can just say color dot cyan. If you really want to, you can create a new color using, color aqua equals new color, and then it takes the RGB values for you. The distance that we want the light to traverse, let's just say 100. I believe that's what the distance does. And then we can just say width divided by 2. Whoops. I hate that when I want to put parentheses for math, it really dislikes me. Width divided by 2 minus 50. And then for the y, we'll do height divided by 2 and then we'll say plus 15. Oops. Handler. Alright. Now, down here, all we have to do to get that light to render is, after we render that, we'll just call ray handler dot, it's not ray handler, handler dot update and render. And I should work. Yep, only our light doesn't really go as far as we want. And let's just up this an extra 0. Might be a little far, a little excessive, but we can adjust it. Now, alright, so we've got a light there. You can see that it's not going past the floor, but you're looking at those shadows and you're saying, if you were paying attention at the beginning, you're saying this shadow looks nowhere near as soft and smooth as the shadows were at the beginning of the video. And that's because of this. If we go back to our main and we see we have useGL 2.0 is false, let's just set that to true, run it. And now you can see that the shadow is a lot smoother, it's a lot nicer. Let's make this 400. And look at that. We have a pretty cool effect. If we want to use a cone light, which we can do, we can just say new cone light. Takes our handler. We'll give it, we'll try to kill my GPU. Let's make it pink. Cyan and pink. Woo! The X will make it width divided by 2. And instead of subtracting 50 this time, we'll just add 50. Plus 50. We'll make the Y the exact same value. And the direction degree is... Why do you hate that I want to put my handler? Oh, okay, the direction is the degree in which it's facing. I think 180 is, I forget, 90. And the cone degree is how wide of an angle that it should shine. So we'll say it should shine 35 degrees. And that parenthesis doesn't need to be there. Let's run this now, and it's actually pointing there, so we need to say 270. And looky there. Kind of an interesting effect, since it's pink with the blue, it's making it white, except where the shadow is, where it's kind of a reddish. Actually, kind of, let's see what that looks like with without the other point light. This is where it's kind of fun to play around with and really see what kind of effects that you can really make. It's actually kind of a cool, almost makes me think of if you were making a side scroller. Be a really cool for like a street light, and you have someone that just kind of, you know, runs through and you can only see inside the street light kind of a thing. I don't know. It'd be fun to play around with in a game jam, but there you guys have it. My brief tutorial on Box2D and lighting effects. I hope you enjoyed it, and I will see you guys later.